Hi guys, this is Anjali from Simplilearn, and today we look into the tutorial on the configuration management tool Puppet. So before we start, one thing I'd like to mention is that Puppet falls on the ops side of the DevOps approach. So let's begin. So what will we learn today? Today you'll learn about why we should use Puppet, what exactly is Puppet, the Puppet architecture, how Puppet works, and finally we'll have a demo on the installation of Apache on our node. So let's begin. Why Puppet? So consider the scenario of an MNC. The MNC puts together the small team of system administrators. They're responsible for taking care of the infrastructure of this organization. Now this infrastructure could consist of data centers, server centers, and many such components. Fortunately for the MNC, they were doing extremely well. So the number of clients kept growing consistently, and with this came a boom in the infrastructure size. Now here is where the problem came in. With such a large infrastructure, the small team that they put together in no way could manage this. So what do we do? The solution seems pretty simple, right? Just increase the size of the team. Sure, we'll increase the size of the team. But when do you think we can put an upper limit on the size? When do we get to stabilize this team? So here is where Puppet comes in. With Puppet, a small team is enough to take care of this large infrastructure. This is because the data centers, server centers, all of them can be updated in a matter of seconds with Puppet. Entire load of doing so has now shifted from the team onto the tool. Not only this, with Puppet, if servers do fail, and there's a very high chance of servers failing when you're considering an organization the scale of an MNC, Puppet can instantly roll them back to their previous working states. And if that wasn't enough, Puppet also provides the capability to deploy servers on demand and enforce security on them. Now all of this is done through simple coding which is written in Ruby. We'll look at how Puppet works more. So now that we know why we should use Puppet, let's have a look at what exactly is Puppet. So first and foremost, Puppet is a configuration management tool, as I already mentioned in the beginning of this video. So this simply means that Puppet ensures that all your systems are maintained at a consistent state. So consider that you want to deploy a number of servers. Now you require these servers to be identical. If this task is given to a human, there's a very good chance that those systems will not be identical, or some of them may even fail. Humans are prone to errors, you cannot blame them. So Puppet ensures that all these servers are deployed on time and they are identical. Secondly, Puppet is also a deployment tool. This simply means that Puppet has the capability to deploy your applications, your services, your softwares, all of this on your nodes automatically. And finally, Puppet implements infrastructure as code. Now this term infrastructure as code is a very important one when it comes to the DevOps approach. You would have noticed this term being used in our previous video on Chef 2. If not, you can always click the top right corner to know more. So what does this term infrastructure as code mean? Infrastructure as code simply means that all your policies, your tasks, your instructions, everything is written in coded format. So in case of Puppet specifically, all of this is written in the Ruby language. So now that we know what Puppet is, let's look into the Puppet architecture. So Puppet has a master-slave architecture. As you can see here, on the top we have the Puppet master and below we have the Puppet clients. So the Puppet master is the system where your system administrator sits. The clients are those systems which require configuration. You can have n number of clients connected to the Puppet master. So don't worry, we'll look into each of these components in detail. Firstly, we have the Puppet master. So the Puppet master is where the system administrator sits and he or she types in the codes here. So the codes are not only written in the system, but they are also stored here. And whenever the client requires these codes for their configuration, they simply request it. So manifest is the first subcomponent of the Puppet master. These are the actual files where the codes are written. So in case of Puppet, these are Ruby files. Modules tie manifests, templates, and files into a single unit. Now these codes dictate the instructions for performing various tasks on your client. The next component is templates. So if manifests are your code, templates are the data. So let me explain this to you with an example. Consider you want to create a file called index.html on one of your client machines. So what you do is, you write the code for creating this file in your manifest and the content of this file is written in your templates. Then you simply link them. But here's the thing, when you divide your code and data in this way, it's a very clean structure. So it's preferred to do it in this manner. Files are your static contents. So the files are basically sent to your client and they are simply downloaded at the client. There is no execution or compilation involved with your files. Now this is where files and templates are extremely different, because with templates, they are never sent over to your client. The templates are simply read by the parser at the master itself. Modules ties the manifest templates and files into a single unit. So modules is not a separate component as such, it just provides a very clean hierarchy. This is the most important component of the Puppet Master, CA, which stands for Certificate Authority. Now, as we will see later in this video, the Puppet Master and the Puppet Client communicate through an exchange of SSL certificates. So when the client sends over the certificate to the master, CA provides the master the authority to sign these certificates. The minute the master signs a certificate, the master is basically saying that yes, this client is registered with me and I agree to exchange data with this client. Our next component, Puppet Client, of course these are the systems that require to be configured. Agent is a service installed on the client. The agent is solely responsible for all the communication between the master and the client. And finally, we have Factor. So Factor is responsible for collecting all the data about the present state of our clients and sending this data over to the Puppet Master. At the master, this data is compared against the manifests, which are your code files, and then these manifests are sent over to the client depending upon the results of this comparison. So now that we had a look at the various components of Puppet, let's see how these work together. So we have a master and we have 3 clients. Now before any information can be transferred between the master and the client, it's important that these components recognize each other. Also, there needs to be an encrypted channel of communication between each pair of master and client. Now all the data which is transferred between the master and the client, it flows through this channel. So let's see how this entire procedure of recognizing each other works. The core of this procedure are the SSL certificates. SSL stands for Secure Socket Layer. Secure Socket Layer is a security protocol and it forms an encrypted channel between 2 components. What this encrypted channel ensures is that all the data that is passed through this channel is not accessible by any other system outside. So it provides complete security. Okay, so we will consider a very general scenario. We have a master and a client here. This is not the Puppet Master or the Puppet Client. They are just 2 systems and we are just going forward with master-slave architecture. So the client so far is not a client. It is just a system and we will refer to the system as System A. So System A sends over a client certificate to the master. Associated with this client certificate is the host name of System A. Now master goes through this certificate. It sees the host name and then it decides whether it wants to form a communication link with the System A. If it does, it signs the certificate and the signed certificate is sent back to System A. Now the System A is officially a client. The minute the master signed the client certificate, it said that yes, I am willing to exchange information with this system and I do take the system as one of my clients. So now that the system is officially a client, it can request for data from the master and the master will simply send over the data. Now we are here to talk about Puppet. So if this was a Puppet Master and this was a Puppet Client, then the first 3 stages will be the same. So the Puppet Client sends over the certificate to the master signs the certificate, sends it back, and the client requests for data. Now by data here, of course, we mean the configuration data. Those are the manifests or even could be your files. So what happens after this request? After this request, the Factor service which is present on your clients collects all the information regarding the present state of your client. So this information could include the operating system that's installed on them, the various number of software present on them, the versions of these software. Now all this information is collected, it's called the fact and it's sent over to the master. At the master, this information, that is the facts, is compared against the manifest. So why does the master do this? The master basically compares the facts against the manifest to know if what the manifest is about to perform is already performed on these systems. So if the manifest has some additional functionality, they are compiled into catalogs, and then these catalogs are sent over to the client. Now remember those agent services which existed in your clients? Here's where they come in. The agents take the catalog and execute them on the client. Once executed, these catalogs make the required changes on the client and a report is generated. This report is then sent back to the master. So the master keeps record of all the changes that's made in the system, and this comes very handy when one of the systems fail and it's required to be rolled back to its previous working state. So this entire procedure can be repeated n number of times and can be repeated at regular intervals. So if you have a scenario where a system needs to be configured every 30 minutes, what you can do is you can set your interval and automatically every 30 minutes, your systems will be configured. And we reach the final and the most exciting part of our video, which is the hands-on. So today I'll be showing you how you can use Puppet to install Apache on one of your client machines. So we'll be using two machines here. We'll have a server and we'll have a node machine. The server is essentially your master. The node is your client. I'm just using the term server and node instead because I want to keep it very close to as they are used in the commands. Now both these machines are going to be CentOS 7 machines, and I have Oracle VM VirtualBox installed on my machine. So on that I've simply created two virtual boxes, both CentOS 7 of course. So before we move on to the actual demo, I'll just take you through the various steps. So first we'll install the Puppet server on our server or master machine. We'll then start this server service. We then shift over to our node or the client machine and we'll install the Puppet agent service. We will then start this service too. And the minute you start the Puppet agent service, an SSL certificate is created. So this certificate will have the host name of your node attached to it. And this is how the master or the server will recognize this certificate and then it'll sign this certificate. So once your master or the server signs the certificate, you can write your manifest. So the manifest has just the code for configuration, and once that too is done, you shift back to your client or the node system and you run the agent service. So once you run the agent service, your manifest or your catalogs, because as you know, the manifests are compiled into catalogs, these are executed on your node and this will make the required changes. So that's how this entire process is going to work. Now let's move on to the actual demo. This is my Oracle VM VirtualBox Manager. The last two machines you see here are the ones we'll be using for this demo. The Puppet server is your Puppet master, Puppet client, of course, is the client. So let's just have a look at these two machines. This is my Puppet server. So just so you can differentiate, guys, the terminals have been set accordingly. Puppet server has a black background with white text, and Puppet client here has a black background with green text. So we'll move on to server machine or the master machine, because that's the one we'll be working on first. So before we begin, we need to set the host name of our master to Puppet. So this is a very essential step in the configuration of Puppet. If you miss this out, there are quite a lot of other changes you'll have to make in certain files. So let's do this first. So that's the command to set the host name. The last word you see there, that's the new host name you want. Okay, so now we'll just check if our host name is set. So just type host name. And yeah, it's Puppet. So next, we will check the IP of this machine. So for that, you just type ifconfig. Enter. So this is your IP, guys, under ENP0S3 init's value, that is 192.168.2.183. Of course, the IP will differ for you guys, needless to say. So note that down somewhere because we'll require it when we are configuring our client. Okay, so now you want your Puppet server and your client to communicate. So for this, we need to remove certain firewalls. So the command for this is sudo, because we want the root permission, systemctl stop firewall D and put in the password. Okay, so all your firewalls are removed. So the next step, now we start on with our Puppet process. So we download the Puppet labs at first. Now guys, ensure that your systems, your virtual boxes in this case, are connected to the net. Also, you won't be getting an IP if it's not for the first time. So here's the command to download the Puppet lab. Enter the password again. Okay, so the Puppet Labs is downloaded. Now you need to install this. So installation guys, we will be installing the Puppet server on the master machine or the Puppet server machine. So this may take a while. So that took a while, so I just skipped to the last part where it's completed. The installation process is over. Now we need to make a small change in our system config Puppet server file. So let's just move to the file first. This file will open in VI editor. So this line here, it basically allocates memory for your Puppet server. Now you do not need 2 GB. So we are going to reduce this size. "512 MB should be enough. So guys, notice here I did not type the B, okay? So I just changed this to XMS 512M. Let's save that. Always remember to open this file using sudo. Otherwise, saving the changes you made could be quite troublesome. Okay, so now we can start our Puppet server service. We enable the service. Okay, so that's done. So basically our Puppet server service has started. It's running presently. So for a while we are done with the server machine. Let's move on to our client machine. Okay, first things first, we open our etc host file with sudo because you need to make a few changes and save it. Open this in the vi terminal. Okay guys, so here you have to add this one line at the end. Type in the IP for your Puppet server machine. Puppet dash master. So let's save this file. Now we'll move on to downloading Puppet Labs on our Puppet client. So the command is the same that we use for Puppet server. So Puppet Labs is downloaded. Now we need to install the Puppet agent service here. Again, this will also take some time. Puppet server is installed. Let me just clear this window. Now that our Puppet agent service is installed, we'll start this service. So I'll just type in the command for starting the Puppet agent service. As you can see here, ensure changed stop to running. So basically the service was not running before and now it's changed to the running state. And while we executed this command, not only did the service start running, but an SSL certificate was also created. So this certificate should have the host name of this machine, that's a Puppet client machine, attached to it. So let's just check what the host name of our machine is. That's localhost.localdomain. So our certificate should have this attached to it. So guys, the first time your client sends a certificate, the name of the certificate itself is usually the host name of the machine. So our certificate's name should be localhost.localdomain. We'll check this on our master system, and that's where we'll assign the certificate to. So first we list out all the certificates. In our case, since we have just one client and we just started the client, we should have technically just one certificate, and it will be so. Yeah, so this is our certificate localhost.localdomain. We'll now sign the certificate. Okay, sorry about that. Just need to remove these brackets. Yeah, as you can see here, the certificate is signed. Signed certificate request here. So once the certificate is signed, the request for signing the certificate is removed. That's this line. Now that a certificate is signed, we can begin to write our manifest. So let's move into a manifest folder and we'll create a placeholder file. So we'll create a file called sample.pp. This is just a sample file. We won't be writing anything in this file as of now. So we are just checking here. We are just creating this file and then we'll go to our client machine and just check there if we can access this file from there. So now we'll move to our client machine. So let's test the connection. So as you can see here, it says applied catalog in 0.03 seconds. So our catalog is executed on our client machine. Now our catalog was just a placeholder basically. So the file that we created, which is sample.pp, had no content and we were just testing our client. Now let's go back to our master server, put some content into this file and see how the execution takes place. So we'll open our file sample.pp, which we created earlier in the VI editor. Let's type our code here. So node, and then within the brackets, we enter the host name of our client machine. So this ensures that our manifest is executed on this particular machine. Now the Apache service package on CentOS is called the HTTPD. So this line that I just typed in is the action. It will ensure that the HTTPD package is installed on your client. And that's it. So this is our code. We'll save it. Now let's go back to our client machine and test it. So this is our client machine. And our catalog's applied on the client. So I just cleared the screen. Now we'll start the Apache service. Okay, so how do we see if it's running? We just need to go to our browser and at localhost, you must have the testing page for your Apache. So we type localhost, enter. And yeah, this is the testing page for Apache. So as you can see, we have successfully used Puppet to install the Apache service on our Puppet client. And this is the end of our demo. And with that, we also come to an end of our video. So let's go through everything we learned today. At first, we looked at why we should use Puppet. Then what exactly is Puppet? We had a look at the Puppet architecture and then how these components work together to provide the Puppet capability. We also saw the exchange of SSL certification. And finally, we had a demo on installation of Apache on one of our clients using Puppet. Hope you all found this video informative and it answered all your questions regarding Puppet. If so, please hit the like button. Also subscribe to our channel if you haven't yet. This is Anjali signing off. Thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.